Hello guys, so we're going to go through 4.6 today, which is talking about medians at altitudes. Feel free to pause this video at any time to write down the definitions I already have in there, or when I tell you guys to try some problems on your own as well. So today we're going to first talk about median. A median is a segment drawn from a vertex to the midpoint of the opposite side. So it goes from vertex to midpoint. So I'm going to draw one example or two and have you guys try one here. So this first one says draw the median to BC. So here is BC. So it's going to go from the vertex A, to the midpoint of BC. So let's say here's our midpoint. I'm going to draw a line from there to there. That would be our median. Okay, it went from the vertex to the midpoint, which we now know that these two segments down here are congruent. Okay, we want to make sure we do mark those congruent segments. Next one is draw the median to DF. So here's DF. We're going to go from the other side, the other vertex, so vertex E, to the midpoint of DF, roughly there. And we've created two congruent parts. Now, you're going to do your best. It might not be perfect, but by marking those segments off there, you're marking that they are congruent. So let's have you guys try to do GE. So you can pause the video right now, try to draw the part C, and then come back and check. Okay, so if we look down here, we want to mark to GI. That means we're going from vertex H. Okay. You might want to put a little mark on GI to find where that midpoint is first, so then it's a little bit easier to just connect the dots there. And there we have it. There is our third median for today. And hopefully you're able to find those. Now, when we talk about the concurrency of the medians of a triangle, what we're really talking about is the intersection. So if you look at the image on the right, okay, the point of concurrency of the medians, the point where all the medians intersect, is called the centroid. The centroid is basically the center of gravity of that triangle that we have. Now there's something that is true about the medians in relationship to the centroid. The medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So if I were to look at this first part here, AP is 2/3 the length of the entire median. So the distance from the vertex to the centroid is 2/3 the length of the entire median there. So if you're going to draw this little sketch down here, I'll call this over here will be my vertex right here. We'll put another point. This will be my centroid. And then our last point over here will be, that would be our midpoint on the other end. What we know to be true about this, okay, is if we imagine this entire line right here being three parts. Let's call it 3x. From the vertex to the centroid would be 2x, and from the centroid to the midpoint would be x. Okay. So let's try using that knowledge for the problem below. So use the centroid of a triangle to solve for the following lengths. So they give us some lengths. They tell us MO is 8. So MO is 8 right here. They tell us OP is 5. EL is 6. And OL is 8.4. So let's just try to label as many other things as we can here. Okay? So imagine from O to M, this part right here. Okay, that's the longer part of that full median. So that would be 2x. So 2x equals 8. Well, if I divide that over, that means x would equal 4. So that'd be the second part, using that relationship that we talked about right up here. Okay, so if we looked at this part here, again, LO would be the longer part of that median. If that is 2x, well, then half of that would be 4.2. So that's going to be the other side. So biggest thing you just need to realize is those two sections, okay, the smaller one is half the larger one. Or you can think about the larger one is twice the size of the smaller one. And then if we have this last one here, PO is 5. That is the smaller spot, right? That's from the centroid out to the midpoint. That's my X, which means OS would be twice of that. It'd be 2X, which is 10. Let's see if we have enough to answer the questions that were being asked. So they wanted OE. We got OE. That was 4. They want OS. We found that. That was 10. PS. Ooh, that's the entire segment there. So that's 10 plus 5, which is 15. And then OI we found was 4.2. Hey, the last question they asked there, perimeter of triangle OSL. So we go connect those 3 points, so O, S to L, and back up. Well, if we look there, we have a side of 10. We have 8.4. We have part of this is 6. And then, well, if we remember, ME is the median, which means that these two parts would be equal. So that would also be 6. And that adds up to 30.4. You guys will get a very similar problem on your homework tonight. Next, we're going to practice finding the centroid of each triangle. So I'm going to have you guys do that on your own. So I'd like you to pause the video right now and try to find the centroid on your own. Remember, that means you're going to draw the median from each vertex, and your points of those lines should intersect at one point in the middle. Okay, let's take a look and see how we did here. So for our cute one, okay, trying to estimate where that middle would be. Okay, again, these would then be congruent. We go to the far vertex here. These would be congruent, and then, oops, that was not a very good drawn one there. There we go. We should find the centroid to land right there in the middle. Okay, again, sorry about those bad labels there. And we should have an equal tick marks for those. So these two sides are the same, these two and these two. If we look at this for a right triangle now, same thing, dropping down to the, from vertex to midpoint, from vertex to midpoint, and from vertex to midpoint. Congruent sides. Now, it might not be perfect, but our whole goal is when we do this, we should end up seeing that point where they meet in the middle. And again, that is your centroid. And then finally with the obtuse, And we're going to end up with all of our congruent sides. So hopefully you notice, where's the centroid always located? The centroid is always inside the triangle. Okay, the centroid is always inside the triangle. Okay, that might not be too important to you now, but that will come and be something important to us in a little bit.